Okay, this is our second FRQ question. Hopefully this one will be a little faster than the first. We have less stuff to read, so less information to figure out, but we have, let f be the function defined by this. We have this function here on a specific interval. On this interval, hopefully my thing is working. Please load. There we go. Okay. All right. So first off, find the x-intercepts. This question, I haven't asked a question like this before, but this is, I guess this would be probably a pre-cal question because we're doing trig functions. But x-intercepts are where f of x equals 0. So we want sine squared of x minus sine of x to equal 0. And I saw some of y'all, and when I say some, I remember it specifically on one person's paper. You added, it's taking a long time to, please update. Let me see if I can fix this. I don't know. I don't know how to fix it. Let me pause real quick. Okay, hopefully that fixed it. All right, so as I was saying, I saw some of y'all add sine x to both sides, and you get sine squared of x equals sine of x. And this would give you some of the solutions, but it wouldn't give you everything because we have this squared. Let's see. I think I'm still having difficulties rendering, so I might have to, there we go, okay. So we really shouldn't do this because there's a better strategy that we can use. What we can do is we can factor this because we have two terms and both terms have a sign in them. So let's factor out a sine of x, and we're left with sine of x minus 1 equals 0. And now that we have two factors, all we need to do here is we need to set each factor to 0. So we need to say sine of x equals 0 and sine of x minus 1 equals 0. And we're specifically only looking at our intervals 0 to 3 pi over 2. So I don't want to go the whole unit circle, and I want to go 75% of it. So sine equals 0 when x equals 0, because 0 is on our interval. When x equals pi, and that's it, only at 0 and pi. Because the next one would be 2 pi, which 2 pi is not on our interval. All right, and then we have our sine x minus 1. Well, this means that sine of x equals 1, which means we're looking for x values where sine would be 1. Well, there's only one place on the unit circle where sine of x equals 1, and that's at the pi over 2 location, which, if we had a longer interval, could be other places as well, but this is the only spot on our interval that we're positive 1. So our x-intercepts are 0, and I'll put it in order. 0, pi over 2, and pi. And when I say put in order, I mean least to greatest. That doesn't super matter. The order doesn't matter, but there's your 3 points. Okay, one part down. That was worth 1 point right there because this really wasn't that intense of a question. Now we need to find intervals where f is increasing. All right, find intervals where f is increasing. Well, f is increasing. I just did something that I didn't want to do. F is increasing when f prime is positive, when f prime is greater than 0. So what do we need to do first? Well, we need to find f prime. And if I'm looking at my two functions here, well, I have my original function, sine squared x minus sine x, and I also have my factored version, which is sine of x times sine of x minus 1. Well, this one I highlighted in yellow is going to be easier to take the derivative of than this bottom one here because I don't want to use the product rule if I don't have to. So I'm going to do the derivative of the top one, although it should give you the same answer. And we get f prime equals, I tried to help y'all out and I gave you a warm-up question asking you what the derivative of sine squared of x is. The derivative of sine squared of x is 2 sine x, that's our power rule, times cosine x, and that's our chain rule. 2 sine x using our power rule times the derivative of our inside function, which is cosine x minus cosine x. And we want to find our critical points, so we want f prime to equal 0. By the way, just to say it now, this line right here that should show up in a second is worth one point. Finding the derivative on its own, that was worth 1 point. Okay. And now we need to find our critical points. Well, let's rearrange f prime. We're going to factor because both terms have a cosine in them. So we're going to pull out a cosine. We get cosine x times 2 sine x minus 1. Okay. And we have factors, set our factors equal to 0. Cosine of x equals 0. That one will be really fast. Cosine of x equals 0 implies that x equals pi over 2 and 3 pi over 2. Because 3 pi over 2 is on our interval, we are including it. This is just knowing your unit circle. And then we have 2 sine of x minus 1 equals 0, which is the same thing as sine of x equals 1/2. I'm skipping a little bit of steps there, but hopefully not too much. Where does sine of x equals 1/2? Well, it equals 1/2 at pi over 6 and 5 pi over 6. All right, I'm running a little bit out of space, so I'm going to make my number line kind of small. And I'm going to do mental math here. Okay, so I'm making my number line from 0 to 3 pi over 2. And I'm putting my critical points on, so we end up with, I'm going to put it in order, pi over 6, and then the next one would be pi over 2, and then 5 pi over 6. All right, and here's where I'm going to do the mental math. All right, if I'm looking from 0 to pi over 6, I'm just going to choose 0 because if we notice, 0 is not a critical point, and it is to the left of pi over 6. Pi over 6 is my critical point. So I'm going to plug in 0. Cosine of 0 is just 1. Sine of 0 is 0, so this is going to end up being 2 times 0 minus 1, which is just negative 1. 1 times negative 1. This first interval is going to be negative. And then from pi over 6 to pi over 2, I'm going to do this two ways. The first way is the more methodical way. I just want a number between pi over 6 and pi over 2. I could choose pi over 4, but I know the pi over 4 is going to give me root 2 over 2 for cosine or sine, and I don't really know radicals that well off the top of my head. So instead, I'm going to choose pi over 3, because pi over 3 will give me cosine of root, I guess never mind. In either case, it works out the same way. I'll still use pi over 3. We get root 3 over 2. I'm sorry, 1/2 for cosine. We get 1/2 for cosine. This is a positive number. All I care about is that this number is positive. So I don't even need to remember that 1/2. I just need to remember that cosine is positive here. And then if we do sine of pi over 3, that's root 3 over 2 times 2, root 3 minus 1. Root 3 minus 1 is also going to be a positive number, because any square root greater than 1 is going to be greater than 1. So this is going to be a positive times a positive number. This interval is positive. Then from pi over 2 to 5 pi over 6, what's an easy one to choose here? Well, I can just choose the next one over. So we did pi over 3 here. 2 pi over 6. So that would be 2 pi over 3 here. And we just need to be clever with our observations here, because sine at 2 pi over 3 is the same thing. So this whole thing will still be positive. And then this cosine, well, I know cosine in the second quadrant is negative. And I would also know that it's a negative 1/2. A negative times a positive is negative. So that's not there. And this idea of using this when cosine and sine are positive and negative in the quadrants is helpful, especially for the cosine. The sine, not as much, because there's other stuff happening, but we can just make the observation that cosine is positive in the first quadrant and the fourth quadrant, and negative in the second and third quadrant, and we don't even need the number for cosine. And then from pi over 6 to 3 pi over 2, let's choose pi. Pi is the easiest one to choose here. Cosine is negative. Sine of pi is 0. This is negative 1. So negative times a negative, that's going to give us a positive. And boom, we did our number line. And now we can say we're increasing. We are increasing where f prime is positive, or f prime is greater than 0. So we're increasing on pi over 6 to pi over 2, and, or in union with, 5 pi over 6, comma, 3 pi over 2, because f prime is positive. And these intervals here, that was worth another point, and saying because f prime is positive, that was worth your third point there for this question. So that was where all three of the points came from on that question. Next one, find the absolute max and minimum. This one, for the people that did this question, I saw a little people tripping up on this question, is you've pretty much done all the work you need to do. It's worth 2 points, one for finding the absolute maximum and one for the absolute minimum. all you had to do was look at our critical points and our endpoints. We also need to evaluate our endpoints. That's the sort of piece you needed to remember. So we need to evaluate f of 0. We need to evaluate f of pi over 6, f of pi over 2, f of 5 pi over 6, and f of 3 pi over 2. So we need to evaluate all those things. I'm going to do mental math here to save myself a little bit of time. F of 0, so I'm substituting 0 into, well, I'll do the first one, and then I'll do mental math for the other ones, just so you can see my process. We're doing sine squared of 0 minus sine of 0 equals sine of 0 is 0, so 0 minus 0, this is just 0. F of pi over 6, this is 1/2 squared, which is 1/4, minus 1/2, which is negative 1/4. That's that one. Pi over 2, sine is 1, 1 minus 1 is 0. Well, 1 squared is 1. Let me make that observation as well. 5 pi over 6, this is going to end up being the same thing as pi over 6 because sine is the same at pi over 6 and 5 pi over 6. And then finally 3 pi over 2, sine is negative 1. Negative 1 squared is positive 1. Positive 1 minus negative 1 is positive 1. I'm sorry, positive 2. Positive 2. And so now what we're looking for values, absolute max value, absolute minimum value. So our absolute minimum, or I'll do maximum first since that's what I asked for first. Absolute max value is 2, and the absolute minimum value is negative 1/4. And even though at pi over 6 and 5 pi over 6, it's the same number, this is still our minimum value. We still have a minimum at pi over 6 and 5 pi over 6 because both of these numbers are our smallest number. So just because it's two of them, it still meets the definition to be a minimum. If we had a more rigorous definition of minimum, that would make more sense. But I'll just sort of say it as there's no number smaller than negative 1/4 on our interval. So it's our absolute minimum. All right, question D. This question was looking tricky, but really is not that tricky. This is just a sort of hidden limit question. And some of y'all did it in an interesting way. If you try to find this limit, you end up getting 0/0, which is indeterminate. And if you want to, once you've shown that it's indeterminate, which you can show that by saying the limit as x approaches 3 pi over 2 of f of x minus f of 3 pi over 2 equals 0. Limit as x approaches 3 pi. I'll refresh it in a second of x minus 3 pi over 2 equals 0. So we're indeterminate. So we can use L'Hopital's rule. And then we can say that the limit as x approaches 3 pi over 2 of f prime of x divided by 1. And I want to note here what's happening when I take the derivative. This is our function. f of x is our function. The derivative of our function is f prime. F of 3 pi over 2 is just a number. This is just a constant. The derivative of a constant is just 0. As we see down here, our function is x, the derivative of x is 1, and minus 3 pi over 2, this is just a constant. This is just a number. This goes to 0. So if you look at this, and maybe you'll see it now, this is just equal to f prime of 3 pi over 2. This is just our alternate definition of the derivative. This is just another way to ask for what is the derivative at a specific point. What is f prime of 3 pi over 2? But using our limit rules, we can still get to there. But we're just asking for what is f prime of 3 pi over 2. We already found f prime. It was our 2 sine x cosine x minus cosine x. So I'm just going to substitute that in there. F prime of 3 pi over 2 equals 2 sine of 3 pi over 2. I think using the factored form actually might have been easier here, by the way, but it's too late. I'm already committed to this way. Yes, I'm not, but I am at the same time. Okay. Cosine of 3 pi over 2 is just 0. Okay, so in both cases, it doesn't even matter. This term goes to 0, this term goes to 0. 0 minus 0 is just 0. And also, the alternative thing we could have done here is we could have even observed up here that we found 3 pi over 2 is a critical point. Well, what does that mean about f prime of 3 pi over 2? It means it's 0 or undefined, and we know it's 0 in this case, so our function is never undefined. So getting to 0, that was a point there. And then E, is there a C such that f prime of C equals 4 over 3 pi on 0 to 3 pi over 2? Justify your answer. The big theorem that I had in mind, although someone did prove it a different way, which I thought was very clever, is we're looking to justify that f prime of C equals some value. If we're trying to prove that f prime of C equals something, this is our clue that we should probably be using MVT. So let's just start writing our thing. F is continuous and differentiable. And I'm not even going to put my interval, because the reason I'm not putting it here is because this function is always continuous and differentiable. It's not just continuous and differentiable on this interval. I can broaden it and say it's just continuous and differentiable because it is continuous and differentiable at every single point. So me saying it's continuous and differentiable implies that it's continuous on the closed interval 0 to 3 pi over 2 and differentiable on the open interval 0 to 3 pi over 2. So just, if you don't have to restrict yourself to that interval when you're using your theorems. If it makes you feel better to write it out every time, you can, but just to save myself a little time. And then we're going to say, then f of 3 pi over 2 minus f of 0 over 3 pi over 2 minus 0 equals, I'm going to just do the mental math. You can work it out. You can work it out on your own. It gives you 4 over 3 pi. So by MVT, there is a C such that, oh, sorry, I should refresh it. You can't see what I'm writing. I'm going to use an abbreviation here. ST means such that. You don't have to use that abbreviation, but you can if you want to. It's actually a very common math abbreviation. I used it a lot in college when I was writing proofs. Such that f prime of C equals 4 over 3 pi on 0 to 3 pi over 2. And here I am writing the interval because the question is specifically asking about on this interval. And I used stuff from this interval, like our theorem guarantees it on that interval. So here you do need to write the interval. Yeah. And this was question 2, another 25-minute one.